In this lesson, we'll be discussing best fit line. By the end of the lesson, you should be able to create a trend line to make predictions and write an equation for that line of best fit. So best fit line is a line that passes as close to the data points as you can get. It's also called a trend line. And if the points are really close to the best fit line, that means it's a strong correlation. And if they're further away from the best fit line, it might be a weaker correlation. So in this one, when we draw this line, most of our points are very close, so it's a strong correlation. In this one, when I draw my best fit line, the points are close, but not as close as this one, so it's a weaker relationship. We can also write an equation to model that line of best fit. So y equals mx plus b. We find the slope. Either you're counting your boxes up and over, or you're just taking 2 points, y2 minus y1 over x2 minus x1. We also have to have the y-intercept. So you might just look at the graph to find it, or you might have to use the slope and 1 point, fill in what you know on the equation, and solve for b. So in this example, the m is 1, because if I choose 2 points, I go up 2 over 2. 2 divided by 2 is 1. Our y-intercept, you can see that that goes right through, so it's 4. So our equation is y equals 1x plus 4. So let's do some examples. Write an equation for the best fit line using 2 points from the graph. So the first thing we're going to do is find our slope. So we can just choose 2 points. We want to use the ones that are on the graph, so we'll count down 2 and right 2. So our slope is -1. Our intercept is right here, where the line crosses the y-axis, so it's 14. So our equation is y equals -1x plus 14. Now sometimes it's not quite so obvious on that y-intercept. So let's find the slope, but this time let's do it from 2 points. So y2, 7, minus y1, 4. 7 minus 4 is 3. Over x2, which is 9, over x1, which is 3. So 9 minus 3 is 6. We simplified 3/6 to 1/2, so our slope is 1/2. Now we don't have the intercept, and even if we drew that line, it would go somewhere between 2 and 3, so I wouldn't be able to tell exactly. So I'll start with our equation y equals mx plus b. This time I know a y, I know an x, and I know an m. I just need the b. So I get the y and the x from either of these points. It doesn't matter. So I'm going to use the 3, 4 point just because it's a little easier numbers. So I fill in the y, which is 4, equals 1/2, which is the slope I got up here, times 3, which is the x value, plus b. So now I just solve for b. 4 equals, half of 3 is 1.5, so 1/2 times 3, plus b. Then I subtract 1.5 from both sides, and I get 2.5 equals b. So now I have the m and the b. I can write my equation. So to write an equation of best fit line, see that this is our straight line, but it is linear, but it doesn't connect all the dots. So to write it, I need my slope. So this is going to go up 3 over 2, so that's my slope, and it starts at 0, 0. So y equals 3/2 x. This one here, my slope is up 200 over 6. So y equals 33, and I can see that my slope here, or my y-intercept is 100. Y equals 33x plus 100. And this one down here, the brown one, it's a negative slope, so I'm going down 1, right 2, so that's -1/2, and my intercept is up here at 8. In this blue one, my slope is up 15 over 3, so 15 divided by 3 is 5, and my intercept is right here at 25, so y equals 5x plus 25. So what's the difference between a strong and weak correlation? It's just how many points are close to the line. If they're very close, it's a strong correlation. If they're not as close, it's a weak correlation. What is the equation for line of best fit? It's the same as a linear equation, y equals mx plus b.